Hello there, my name is Bruce Rain from Brankus Creations, and that is confirmed and validated. Don't accept substitutes. Hello to everyone. Hello Steve, hello Jay, hello Dana, hello Charlie, hello Trina. And if there's anyone who is joining this stream for the first time, please jump on and say hello. I do hope that the picture and audio are all good. My sort of screen seems a little bit, my camera's a little bit kind of low frame ratey type thing at the moment, but I have no idea why, and I'm not going to go around restarting this computer and trying to figure it out. So that's that. Okay, so obviously the purpose of this stream is to recap a Macintosh LC power supply. Oh dear, yes. Now, Steve has actually just brought something up of importance, and that is that this channel now has a commercial component. I do apologise, but that is what makes the world go round. So I'd be very interested to know how people go with that. I'll be very interested to know people's opinions on just sort of web advertising in general, because that's something that I am always quite interested in. Yeah, if you've got any thoughts about, whether advertising that you receive you consider it to be relevant to you, or whether you think it's just like nonsense stuff that comes up, I'd really be interested in your opinions. So, okay, so herd pants are optional. That is correct. However, I have opted for pants today. I just think it would be a much better thing. I have moved my microphone. It used to live here. Now it lives here. I'm hoping that, given the fact that I'm facing this way most of the time, talking to the camera, that the audio quality might be a little bit better. So don't worry, Steve, about being late to the party. You haven't missed anything. It's basically just me being interesting. Oh my goodness, look at that. It's my first super chat. And I would like to thank you, Jay, for that, for being my very first super chat ever. So I do appreciate that. Thank you for contributing to the cause. I will try and make this an extra special stream. Steve Mac84 has a little a little routine when he gets a super chat. He does a little Macintosh EAP. I obviously don't want to try and do the same thing. That would just be sort of copying. So maybe every time I get a super chat, I'll sing "I've got a lovely bunch of coconuts" or something like that. So okay, so I think I missed the first part of the question, but I hate all advertising in general. Yeah, I mean, being someone who has worked sort of in marketing, advertising becomes sort of like a necessary evil for kind of making money, I guess. And no one's a huge fan of advertising, but I am someone that believes, well, I actually kind of like advertising that is marketed to me. I like it when I get ads that are relevant to me, or they're about things that I'm interested in. And so obviously when it comes to web advertising, if they are doing it well, that's what you should be seeing. You should be seeing stuff that is relevant to you. If you're, I don't know, if you're seeing ads for dog food and you don't own a dog, then they're really not doing a very good job at all. Okay, so for those who have been watching my previous streams, you may recall that I was working on a Quadra 700. Now, I am going to do a follow-up stream for that, but I just figured I would just take a moment to show people who were interested in that where I got up to. It still doesn't work, I might add, but we have made some steps towards making it look a little bit better. Okay, so no, I didn't say hello to Bill G, so hello Bill G. And I'll say hello to DD Electrical. Hello. Oh, DD Electrical. Hello. This is his LC475 power supply. So there we go. So once again, customers looking, I have to do a really good job. So as I mentioned, I have got this Quadra 700 that I was working on in a previous stream that is in a bit of a shocking mess. So I just thought I would just jump on and show people some of the things that have been done, but I will be doing a follow-up stream specifically on this. So let's just jump across to the microscope now. Now this has been partially cleaned. Specifically just around the bottom of the board here. This is where the worst part is. There's lots of flux on here at the moment, so it looks disgusting. That there is a replacement crystal. I took that off another computer. Let me just get this focus right for you guys, because this often happens when it drifts out a little bit with the camera. So let's do that. Where am I? There. I think there. But basically what I do is I try and get it so it's in focus here for you guys, and then I adjust my focus here so that it matches. So, alright, so we had a missing battery holder. I've now replaced it with a new battery holder. We had a whole bunch of missing traces and components. So there's a diode, there's a resistor, there's a capacitor, and there's a diode. And so there were no traces here, no copper on the board at all. So what I did is I grabbed some component adhesive and I stuck these components down, then I let that adhesive cure, and then I did this lovely bodge wire work. It doesn't look too crash hot, but you know, that's just how it is. Now where we have a problem, and if anyone has a Quadra 700 available and a multimeter that works, I should mention that, because you do need a multimeter that works in order to check this out. Just above R78 here, just near the battery holder, there is a little via. It's a whopping great hole in this board, but there is a via. Oh god, that's a terrible pair of tweezers. There is a via just here, and that joins to the end of this resistor here, and that is completely entirely rotten through, and so far we haven't been able to figure out where it goes. So if you have a Quadra 700 board and you feel like grabbing a multimeter and sticking one end on that, putting it on continuity mode, and then poking the multimeter around to see if you can figure out where that is going, it would be greatly appreciated. There's a good chance it's probably heading towards this chip here somewhere, because this is the real-time clock chip. So that is U92. And that is the real-time clock chip, and so there is a possibility that it is going somewhere there, but I don't know that. So, okay, so, hello, Christopher. Okay, sorry, it's all right. We haven't really done anything. I haven't even started the LC yet, so don't worry about that. I was just catching up on the old Quadra 700 I was working on. So, you know, a lot of these components I have taken off. I have resoldered back onto the board, cleaned up the pads, done all that sort of work. I've done it with 1, 2, 3 DRAM chips. I'll probably end up having to do it for the rest. We've got quite a lot of broken traces around here, but these are basically going to pads that don't even do anything. So I haven't really bothered to fix any of those, though I may. We'll see what happens. We've got broken traces here, but they go to the restart button, so there's no restart button on this at the moment, so there's no real point fixing that. So anyhow, that's where we are with the Quadra 700. Still doesn't work. Light comes on, you know, but no chime, no screen, nothing. So I am still not sure what I'm going to say to the customer about that one, whether I'm going to say, not worth it, forget it, or whether I'm going to invest a little bit more time in it. But at this stage, it's, you know, it's eating up so much of my time. Alright, so just a reminder that I have this pretty side angle. Here's my microphone. And I apologise for how messy my workshop is, but that's just how I roll, man. Now, okay. Dana asks if pliers would help, and we know that Dana's track record with pliers is not particularly good. You do something once and it just, you know, marks you for life, doesn't it, Dana? Right, okay. I do need to do a continuation live video on the Quadra 700. I will do that. I kind of, yeah. one of the problems I have with it is so much of what I've been doing with it has just been sort of repetition, taking a component off, cleaning a pad, putting another component back on. And to be honest, once you've seen that once or twice, that starts to become a pretty boring live stream. But having said that, as I've had sort of people say to me before, you know, let us be the judge of whether it's boring or not. So, you know, I will probably do another live stream. Right, let's start looking at, I'm just going to get this out of the way, like this. And let's start having a look at this. So this is a Macintosh LC475 that was sent to me by a customer, David, who is in the stream. Thank you, Steve, for that super chat. I do appreciate that very much. As I say, I still haven't figured out... Actually, that's a super sticker, isn't it? I still haven't figured out what, you know, little thing I'm going to do when people send me a super chat, whether I'm going to have some sort of little branded thing I do, but for the moment it'll just be thank yous until I figure out something interesting. Now, super chat sticker, whatever the heck it is. Well, it is with sort of like little moving things. It's awesome. I love it. Moving things. All right, so LC475, as we see here. Few little things about the LC475. Okay, it's the only LC with a... Sorry, I shouldn't say that's rubbish. The only LC in this pizza box form factor with a 68040 chip. The original LC was a 68020, and the LC2 and LC3 are 68030s. This is a 68040, which is nice. And once again, it was sold as a low-cost model. I think at the time, you could take it up to with RAM is 36, but I think if you get the right sort of sim, you can take it up to 128 or something like that. It is one of the models... Oh, another thing I should mention, this was also rebadged as a Quadra 605. Same computer, pretty much, I think. Pretty much the same computer. Might have had a different... Was it the LC CPU versus non-LC CPU? I don't know. Steve from Mac84 will be able to tell me that. He'd know that. But for essentially the Quadra 605 was the same as the LC475. But I think the Quadra 75 came with a network card installed. So it was one that you could use with Ethernet straight out of the box. These, of course, you can stick an LC card in them. Type my first document on this LC475, aged 2 months old in July 1996. There you go. Nothing like a bit of nostalgia with the old Macs. Okay. I have a 605 LC3. It's pretty awesome. I got lucky and have 36 megabytes of RAM. That's awesome. Plastic case is a bit different on the 605. Yes, I do believe it is. Do the LC series all use the same PSU? All of the LC pizza box series. Obviously, there's things like the LC575 and 630 and stuff like that. They use a different one. But this small pizza box computer, they do all use the same power supply. They are interchangeable, same connector, same voltage, all that sort of stuff. Now, this is one of the computers that suffers from this horrendous plastic, brittle glass sort of plastic. And when they get old, they just get super brittle. You can actually see quite a bit here. I've got to be super gentle here. I've got to open this up without actually doing further damage. So I'm going to just do this very closely because I really, don't want to break this on a live stream. That would be super embarrassing. Okay, so let's have a look at this case. We've got, let me just grab a little bit of zoominess here. We've got some busted plastic here. We've got some busted plastic here. We've got some busted plastic here. Yeah, so these are just an adventure in busted plastic. I've got one that's the same. It's either an LC475 or a Quadra 605. I can't remember which one it is, but it's one of the two. And it's just virtually everything is broken inside it. You've got all these little plastic tabs here that hold in like things like your floppy drive and your hard drive. This, of course, has none in it at the moment. You've got all these plastic tabs here, and they kind of, in order to remove the drive or whatever, you've got to separate them to lift it up so that the little hook here is released. And, you know, I don't know, most of the time these days when you go to try and take a drive at it, it just snaps off. This one here has lost one of the little plastic things that holds the fan in. My one upstairs has absolutely nothing holding in the fan. The fan's just floating around inside. But the computer still works. I mean, you know, but it's just how it goes with these old ones. The plastic just gets really brittle, and you just have to kind of accept it until someone figures out a way to provide some sort of treatment to make these less brittle. There's not much you can do about it, really. I suppose you could try and maybe warm the plastic up, so it might be a bit more bendy, but even that's probably, you know, prone to failure. Okay, plastic case a bit differently. I've read that. Do the yes. 605 had a 68 LC475. Okay, so that means they were essentially the same computer. I mean, if they both had a 68 LC475 running at 25, which is exactly what this has, 25 megahertz in there. I think the only difference was, as Steve mentioned, was I think the case was slightly different, and they had, I think they came out of the box with an with an Ethernet card connected to the PDS slot, so that they were essentially, if you're buying the LC, it was an Ethernet. If you bought the Quadra 605, it did have Ethernet. So, who have we got here? Fizbin, thank you for joining. I haven't said hello to you yet. Matt, hello, welcome Matt. I think everyone else is covered, so let's just have a quick look here, and we have got 16 viewers, so thank you to all of you for joining. If you haven't jumped on and said hello, please say hello. If I don't say hello back, it's only because I got distracted and didn't see your comment. It's not personal. Okay, so logic board here, power supply here. We need to unplug this here without breaking any plastic, and this is just held in with two little plastic tabs on either side of the power supply here. So I'm just going to try and separate them without snapping them. There we go, which I did, and hooray, there it is. Oh, there's my MacGuffin. For those who don't know what a MacGuffin is, they're a thing in a movie that people are chasing after. So Holy Grail is a MacGuffin. Then what do you call it? Raiders of the Lost Ark, the Ark of the Covenant. That's the MacGuffin. So there you go. There's my MacGuffin. There's the logic board. This is also going to need recapping because, as you can see, all these surface mount electrolytic caps. And as I've often mentioned, we've got a little sound chip down here, which lives right in the middle of these surface mount electrolytic caps. So generally, if you have one of these, if the sound starts to get quiet or goes completely gone, that's because of capacitor leakage. I mean, we can have a look at this under the microscope a little bit later, and we may actually find there's fairly visible leakage. Certainly a lot of dust clinging to that area, but that's mainly because there's no cover on this hole. So obviously when this runs, the air's been sucking in there and pulling dust in. Okay, the PSU isn't the original one. The original one had a black power switch. Isn't that interesting? I've never seen one with a black power switch. Okay, since we are on the topic of Captain 318, hello. Just out of curiosity, the 318 on your name, does that mean anything? Because it is the engine size of a Chrysler small block. Where are we? Also says, did these use different sound chips using... also curious compared to the LS2CI, as I'm wondering if the sound would be different between models. So, the LC475 uses this sound chip here, which I'll just put it on the under the microscope so that we can have a good look at him. Alright. Or we will not have a good look at him because he's not going to fit under the microscope. We might have to try a zoom on the camera instead. So this is the guy here. And there we go. Let's just put that around about there, and then if I go like this, whoops, I should be able to zoom right in on that guy. A bit back a bit, there, back a bit, back a bit. There we go. Okay, so that's the chip there. That's the sound chip. Now, it is quite different to the earlier models, like the CI. The CI, if I remember rightly, I'll double check, but they might even use two sound chips. In the earlier days, they had a single sound chip for one channel of sound, and then when later they started doing stereo, you can definitely see leakage around there. When they did stereo, they would put two sound chips on there, but now this is a stereo chip all in one. And these are really hard to find, and they're very prone to failure. I actually have a couple of boards where the boards are perfectly fine, apart from the fact that they don't have this sound chip on them. You know, it's been rated or whatever, because same sound chip as on the Color Classic from memory. I think the same as on the LC475, I think. So this particular sound chip is used a lot. It's at 343S0129. Now, I have tried to source these. I found a place in China that said they had a whole stack of them. I put in an order, and then they came back and said, we don't have it. So I think they were just sort of trying to get a bit of clickbait by actually having that model number up as an available one. They said they had thousands of them. And then when I said, well, you know, what happened to them? They said, we sold them. I went, yeah, you had thousands of them like a day ago, and you sold them? I mean, like this chip from 1992? Anyhow, okay, so, there's a quake, had to go document it, okay? I apologise, I don't think it's me causing the quakes. I mean, I'm fat, but I'm not that fat. I had previously thought they halted manual inject by the time of the LC475. Well, we'll come back to that in just a second. PSU is in the original. 318 is my birthday. Okay, yes, the 318 is legendary. I've had my share. Excellent. I think I've actually got a 383 in my Chrysler, so a big block. Original PSU was Dyna something brand. Yeah. Okay. Hello, Scarlet Swordfish. Welcome to the stream. Thank you for joining. So just very quickly about the floppy drive. Someone mentioned the whole manual inject, auto inject thing. So auto inject are the floppy drives that were in all of the original old Macs. I do have some floating around here, but it will take me a while to find them. So I'm not a while to find them. I know exactly where they are, but it'll take me a while to grab them. So the early ones are the auto inject, and the idea of the auto inject is you didn't need to go quite as far before the drive would actually pull the disk in. And then you ended up with the manual inject ones, which are the ones that I'm pretty sure this one uses a manual inject. Got a few of them tucked away down there. I'm pretty sure this one used a manual inject, and I think that's why there's that really large indentation at the front, like this, because you had to push the disk in further in order to get the drive to take the disk. Someone can probably confirm that with me, but yeah, I'm pretty sure the 475 used the manual inject, the later type of drive, the one with a little black door at the front of it, whereas I think the earlier LCs used the auto eject one. So someone can confirm that. So I'm hoarding the chips. No. Yeah, I'll tell you what, if I had a good supply of those sound chips, I would be able to get more computers working, because, as I say, they're always right in the middle of capacitors, so they get hit by the leakage really badly, and then often those chips get fried, you know, by shorts and stuff like that, and then, you know, I end up with a computer that I can't do anything with because I don't have a replacement sound chip for it. So very frustrating. Typically have the oval shape. Yeah, that. Yeah, okay. So there were some early LC475s with auto inject. There we go. So we're all being educated on the old 68K Macs. Haven't done a lot of recapping yet, have I? Boy. Okay. So let's get that out of the way. And that's rather precarious, but let's just hope it doesn't fall down. I'm sure it won't. Okay, so recapping. Cheat sheet. There we go. Upside down cheat sheet. If you have a look in the description, you will find a link to a recapping guide for this particular power supply. Unfortunately, it doesn't have part numbers yet, but it will have. Now, there are a few caps on here that I don't bother to replace. I don't bother to replace this great big one. They're quite expensive they're difficult and expensive to source, and they are really not generally prone to failure, these big ones here. Same with this little one down here. That one's really not an issue. Basically, this side of the power supply is not really that much of a problem. It's all this side. And so, let's... anyone see where I put the power supply? Ah, just here. Got it. That's my MacGuffin. Okay, which brand of PSU is this one? This is an Astec. I'm just going to zoom into it so that everyone can see that I've got this awesome zooming camera. No other reason. I don't see any real other point to zoom because it's not needed, but I just like doing it. So this is an Astec power supply, and we are going to need to start pulling this apart. Now there are... Where is it? Oh, this is different to the one I've got. You know what? This is different to the one I've got, which means it could actually have completely different caps in it, which means that this this guide may be completely and totally pointless. We'll see. We'll have to have a look inside. So this is going to be an adventure. We like adventures, don't we? All right. So let's undo some screws here. Let's grab a screwdriver for that purpose. There's one screw that I don't even know if this one needs to be removed, but without knowing the inside of the internals of this power supply intimately, I can't really say. It's going to just be unscrew and find out. This one I'm sure will have to come undone. Let's get a bigger screwdriver, shall we? One where I can get a little bit more torque behind it. There we go. Torque galore. Okay. Right. And we've got another screw here. Should get some light over here, shouldn't I? Look at that. That's better. How's everyone doing at the moment? How is it in their part of the world? There is talk of some relaxing of the lockdown restrictions we have here in Sydney, New South Wales, Australia. So, who knows, we might be able to start doing things again. I miss eating out. I really miss going to restaurants. Okay, top has come off. And we've got a little bit of cardboard flappy thing here, providing some protection. Let's get that out of the way. So, as I mentioned before, these are the capacitors here that are generally going to give us grief. Yep, this is quite different. I'll need to take photos of this, won't I? For my guide. This is me taking a photo. Oh, I should really move that out of the way, shouldn't I? Can I hold that down or something? Click. 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 Okay. Oh, GT, I didn't see you there. Welcome to the stream. All right, so I'm a little bit behind here. Got to look at this. GT, thank you. I do appreciate that. Thank you for the super chat. It is welcomed. Thank you very much. I'm still working out what I'm going to do when people send me a super chat. I was thinking I could do a little dance or sing a song or something like that. Right. Doing pretty nice here. That's good to hear. Scarlet Swordfish. Just about to go get some chocolate ice cream. Ooh, yummy. Yeah, I want some ice cream as well. Right. Okay. So, right. So we, as I say, this is going to be me sort of muddling around a little bit with this because I haven't actually done one of these before, as in this particular power supply, but I'm sure I will be able to figure it out because that's what I do, man. So we've got a little screw just in here, which I'm going to undo. This is holding this, well, it's holding it into the bottom of the case. There's the screw, bottom of the screw coming out, but it's also holding this heatsink here. So there we go. Off, out you come. Thank you. Let's get this washer. This one of the reasons why I use these little magnets. I have these little strong magnets, and I just pick up all the screws in it with those. It just becomes so much easier. There's another screw here, but it doesn't go through to the other side. There is a screw here that is attaching this to ground. I don't know if it's going to stop us from getting this board out. I'm going to have to put my big spooky specs on. Gritty, thank you very much. That's all right. We've just been killing time until you got here, Gritty. Don't worry about it. The main thing that we've discovered is this is a completely different power supply to the ones I've recapped in the past, which means that my guide is useless, and I am having to figure out how to pull it apart because I've never done one of these before. But the hope is that I will have the capacitors in stock, and I'll be able to do it, and everything will be fine. So, on Ken Stream. Oh, well, you're on Ken Stream. I'll have to go back and watch that. I want to see that. Okay. Running into two places now. All right, so let's have a look here and see if there are any more screws. I don't think this one's going to hold it in, so it is possible that this board will just come out now. Now, one thing I can tell you is this is connected by these two wires to the what is it? It's the switch. And I mean, that switch is not going to come out easily. It has to come out the other way. So I'm actually just going to desolder those so that I can remove the power supply and it's not tethered. Now I'm just going to look and see whether we have any labeling on this so I don't get them mixed up. Yes, we do. L and N, live and neutral. And typically brown is indicated by live. With our colouring here in Australia, our mains power cords, they're typically coloured brown for live and blue for neutral and green for ground, earth, obviously. So I've got a little live neutral label on here, so I've got no problem taking these off. I don't need to remember which one went where. Right. Hello, Oz Retro Comp. Might need a recap. Well, I know a guy who recaps, so I can help you. So we've got to get rid of the solder from here. There are, as I have talked about in my streams before, there are a few ways of getting solder out. One is using a solder sucker. Two, I'm just going to move this because I'm going to jump over to the microscope for this. I need to lift it up a bit, get a little bit more height. Okay, so we have, let's jump across to the microscope. Where's my mouse? I can't have lost another one, can I? Oh, here it is. There we go. So let's change across to microscope and let's zoom in on here. So these are our two here. Sorry, that's the case getting in the way. I can't really do much about that for now. But we've basically got this guy here and we've got this guy here. Now, as I mentioned, there are three ways, well, maybe four ways of getting rid of solder. One is you can sort of, yell at it and ask it to leave, but that doesn't usually work. Another is you can use wick, solder wick, which is braided copper like this with flux in it, and it draws the solder in. Another is to use a solder sucker, such as this. And this is a manual kind where you prime it, and then you press a button, and it sucks there. So you get the solder molten with your soldering on, and then you suck the solder up with this. So then the third way, well, fourth way, because as I say, the first way was using harsh words. The other way is to use one of these, which is a sort of vacuum pump solder sucker, which is heated. It's like a soldering iron. It has a little hole in the end, and yeah, I can zoom in on the hole. Zoom, zoom, zoom. There it is. There's a little hole in the end there, and basically that tip heats up and melts the solder, and then you press this button, which operates a little vacuum pump, which then sucks the solder through here and into this chamber here. My chamber looks awful because I dropped it, and it's glass, and it broke into a million pieces, and I've got it all held together with JB Weld. until the replacement arrives. I have ordered 2 replacements because I know I'll drop one again. So I've ordered 2 replacements, and then but in the meantime, this one does work even though it's held together with JB Weld. Incidentally, when you're using these, the solder gets sucked into here and then it hits a filter, and then it obviously cools and then it solidifies. So you can actually just remove this filter. Not easily, I must admit. The process of getting these out is very fiddly. I don't know if the more expensive ones are better, but this is one of the reasons why I dropped it, is I do find it's very fiddly. And so this is the chamber here, all held together with JB Weld. Thank you, JB Weld. And then we have a spring. Try and go, yep, here's a spring. And then we have the zoom. There's my spring. Let's move this stuff out of the way so you can see it. Screwdriver out of the way. And then we have this filter. And they do come with replacement filters because they do obviously die in time. And then there is a glob of solder that has been sucked out and then gone hard on the end of that filter. So that's basically what happens to the solder in the end. It turns into a little lump of bits. But it is a hell of a lot easier than doing it manually, I can tell you that. So, right, so now we put this back together again without wrecking it. So that goes in there. There's a little piece of metal here that holds the filter in place but allows air to get around the sides. And then we grab this without burning ourselves, because that will make me look very silly. And then we put this end in first, like that. And lower that down to there. And then push that in to cock it. And there we go. That's ready to go. Right. But anyhow, that's not how I'm going to take the solder out for this one. I will do that for some of the other ones later on. I'm going to jump across to the microscope, and we are going to remove the solder here. Well, let's do the first one with my manual solder sucker, and we'll do the second one with some wick. So these manual solder suckers do apply an awful lot of suction, so you do need to be careful that you don't accidentally suck away some pads. And there we go, that was me just sucking that away. There's still a bit there. Yeah, I'm having trouble getting at this at the right angle, so let's go from there. Still not doing the best, but I think it's enough. And we should be able to push that pin through. Can I push that pin through? It's got a little barb on the outside. There we go. So that should be fine. I should be able to pull that through from the other side now. Sorry about the focus. This thing is teetering. It's sort of not, it's not stable, so that's why it keeps moving around. And then this one, we'll try the wick, and you can tell me which one you think worked better. Okay. Wick. Wick. Wickety whack. Sorry, out of focus again. My wick is now stuck to it. There we go. As you can see, I've gone through quite a bit of wick here. Wick is not reusable. Once it's loaded up with solder, you have to just cut it up and throw it away. So, there we go. And I might even wick this one a bit too, because the sucker didn't do as well. Alright, so sorry about this going in and out of focus. Once I get this disconnected, this is not going to be a problem anymore. So we've got a wee barb on this one here. We're just going to try and it's still soldered on there a bit. Oh God, this focus thing is a real pain, isn't it? Okay, there we go. Barb and through. There we go. So, in theory, I should now be able to pull those out. Let's just have a look. One's already out. This one's being a little bit more stubborn. So I'm just going to apply some solder as I give it a yank. It's the barb, I think, is stuck inside the hole. There we go. That's out. Okay, so I have removed this so that I can separate this while I work, which is important because I want to be able to work on this nice and free and easily. you know, obviously you could try and do it with that bit of metal attached, but I think you just end up getting so annoyed. Okay, so we've got a great big piece of metal here which is working as a heat sink. We've got a whole bunch of components that are clipped onto it here to spread that heat along. Once again, we do have a great big fat capacitor here, and I'm not going to worry about that. All I'm really going to be worrying about are these capacitors in here. But having said that, I have no idea what the rating is of any of them because I haven't done one of these before. So as each one comes out, I'm going to need to kind of document it. I probably should do a little illustration here, shouldn't I? This is my awesome drawing skills. So we've got one there, and 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 we've got two little ones here and here. So that's my beautiful little drawing. So it actually has less capacitors than the other one. I'll see if I can see what that one is. Well, I'm going to obviously have to take these off and work out what the ratings are. This one will probably be a higher voltage, this one. This one is 47 microfarad 25. Oh, I've got one of them, so I can definitely change that. So we have another one over here. There's over there, and there's my transformer in the middle. So this one was 47 UF 25 volt. And let's start removing these, shall we? I'm going to take one at a time. So, as we talked about before, we have different methods of removing solder. Now, when I'm removing caps, I usually like to just mark out where all the pins are first, so that I can then just remove them all in one go. I just usually do that with like a little pen like this, and I just do a little mark like that. And then I can just turn it over and solder suck all of them at once. So let's have a look. That one there looks like those two. So there's that one, and here's this one. That looks like it'll be those two. Will it be those two? Probably. This is so different to the other power supply. Don't like change. And it's funny that I've done so many of these, and this is the first time that I've actually come across an Astec power supply on one of these. So we've got that, and that. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. That's good. It all adds up. Oh, hang on. I should do this one here. I can't. Oh, that must be it there. Right. Right, let's just catch up on the chat here while I've been looking at all that. So, what's happening here? So, James promotion, yes, good. We're going to come on each version, crowdsource. Sorry I'm late, might need a recap. I have seen some of these. I'm back, I'm Oz. So, Wick. Okay, yes, Wick. Definitely it was the better method for that. There's no doubt about that. This white is making this all go flary. Also, it says this lamp here. Is that the only one you just bought? Also Wick, but Wick looks good. Good, it is good Wick. It's very good Wick. Wick works best, but yeah, you go through lots of it. This is very true. You do go through a lot of it. Biggest problem I have is with parts soldered to ground planes. Yes, that's exactly right. The big problem with parts soldered to ground planes is the ground planes usually have large expanses of copper which suck the heat away. Well, this is always about finding the best ways of getting heat where you need it. And this is one of the reasons why I often add solder to things that I'm trying to remove solder from. And that always seems counterintuitive. You've got this much solder, why would you double it? And the reason for that is that if you're heating that up with a soldering iron, the desoldering station or a normal soldering iron, when you're heating it up, you want to try and get all of the solder molten. Now, when you don't have that much solder, you might actually have trouble getting enough of the soldering iron onto a nice large area of that solder. If you add more solder to it, when you then put the soldering iron on that lump of solder, you're able to sort of get that solder to completely encompass the tip of your soldering iron. And that means that it gets a lot more of the soldering iron's heat onto that solder. And so then it's more likely to then travel right down through the hole and get the whole thing molten, rather than just the tip of it being molten. So the whole thing gets molten and then you can suck it out. So, as I say, it seems kind of counterintuitive to put, sort of solder, more solder onto something that you're trying to remove the solder of, but it is often the way to go. Okay, so, and then clean up the wick. Yes, that's good. Scrap braided wire, strip off shielding and apply flux, and away you go. Yes, I mean, you can definitely do that. You can make your own wick. Look, to be honest, the wick that I buy, this stuff, good wick, I buy it from my local electronics supplier, which is just up the road, and it's not that expensive. I buy it in a roll of 1.5 meters, and that does do me a fair while. And of course, since I've had the machine thingy, I don't go through as much of this anymore either. Right. I have already taken a picture, GT, but in order for me to print it out and then write the sort of ratings, the capacitance on them, capacitance of voltage, I'd have to go and print it out, which would mean leaving. So I can just do the drawing here without having to go anywhere. So I have taken a photo, but I need somewhere to write down those ratings as I remove them. No clean versus regular solder. What's the difference in use? Well, it's interesting. I don't even know what this is. This is the one I always buy, Goodwick, and I don't know whether this is no clean or not. I mean, generally the difference between clean and no clean is the type of flux they use. Some types of flux are acidic, and if you leave them on, they continue to corrode the board. So if you've got a no clean, it means that the flux they're using in it is not acidic, and it's not going to cause corrosion if it's left on the board. Having said that, of course, I will clean this afterwards. So, right. We need to get back to this because we are getting nowhere. All right, so here's one of my little marked out capacitors, and we are not looking at the microscope, so let's do that, and let's make sure we're all in focus. That's not too bad. So once again, let's grab some wick and let it do its magic. Oh, sorry, my soldering iron went cold. There we go. Okay. There we go. And that component is actually starting to fall through now. You may not be able to see it. I do go off camera a bit. These are, because I'm balancing this on the capacitors on the other side, it's a bit wobbly. So it's a little bit hard for me to keep it still. So for that, I apologize. And let's have a look at this one. So this is a little 47 microfarad 25 volt. Oh, and look at what we have here. That, my friends, is electrolyte leakage. And so if there was any doubt about replacing this particular capacitor, or indeed recapping this power supply, let that doubt be gone, because we have leakage. So there we go. And let's see if there's, yep, there's a little bit of a, see, there's the stain on the board. You can see that there. So, yeah, all right. So this is good. This is very good. It's good to be doing it. Some of this stuff, goop left behind, is just residual flux from when the board's made. You know, it's nothing to particularly worry about. You can see that there's kind of this shiny stuff all over. That's not all capacitor leakage, so, you know, don't need to fret too much. All right, so that's that one. That one's already documented, so I can just put that one aside. Let's now move on to another. Here's a nice big one. And as I say, this could all come to a grinding halt if we find there's a capacitor I don't have in stock. I mean, I have a lot of capacitors in stock, but it's just a question of whether I have the right one. So let's do the wiki thing again. Just applying that heat. I'm using a soldering iron tip with a beveled edge, which means I have a flat bottom like this, which allows me to push it down, push down that that wick and get lots and lots of heat onto the surface. I highly recommend using beveled edges. I know it's a personal thing. When you're using soldering irons, you generally go with what you are used to, what you like to use. I used to use conical tips until I found out how effective bevel edges can be at getting heat where you want it. So, so there we go. I'd be going spaz with isopropyl. Yeah, I mean, I will be cleaning this in the end. So, was that a reefer cap that I just saw? Unlikely. I don't think there are any reefers on this. I will just have a quick look here. No, I mean, what you might have caught the transformer, because that's got a bit of discoloration on it, you know, from sort of glue and everything used to hold it together. So you probably just caught a glimpse of the transformer under there, like this guy here. Because yeah, I don't think there are any reefers on this at all. Right, so this big cap here has just been this one has just been desoldered. So I am now going to whip him out. Let me just zoom in a little bit more here. So he's going to come out. There we go. Yep. And then I need to document him as well. Now he's not as bad by the looks of things. Let's have a look. Nope, no leakage on this guy. So isn't that good? This one is 2200 10 volt. Well, I've definitely got 2200 16s if I don't have a 10, so I should be fine with that. 2200 10 volt. Worth mentioning that when you are replacing capacitors, you can go up in voltage, but don't always make sure you match the capacitance, the microfarads there. You want to make sure the capacitance matches, but you can go up in voltage, don't go down in voltage. And also they have a temperature rating. Don't go down in temperature rating either. This one is a 105C. They do, some of them come out in 85 degrees Celsius, but these days most of the ones you buy, you'll find will be 105 degrees Celsius. I generally buy replacements that are long life, ones that are designed to last longer. If you do decide that you want to put a capacitor on there of a higher voltage, it's generally been said to me that you don't want to go up too much because it does impact on the ESR, which is the something resistance, something resistance. I don't know. Someone on here will know. I bet you Bill G knows. Okay. Conical rules. I would, yeah, no, definitely not. Definitely don't like using conical tips. And the main reason why I don't like them is because they have when they have a little fine pointed tip, you might sort of think to yourself, oh, you know, I can do incredibly fine detailed work with them. But because that tip is so small, it doesn't transmit much heat. So when you then go to put it onto something, you don't get the heat to where you want it. So that's generally why I don't like them. If you're using a conical tip sort of on its side, sort of pushing down sideways, yeah, maybe. Or if you're using a tip like this with a bend in it, where you can use this bendy part to actually get some heat where you want it, they're okay. Again, not what I like to use, but you know, they're okay. You can have these sort of, what do they call these ones? I can't remember. They're like a little blade. They're quite good because they have these flat surface areas you can apply and get heat onto what you want. I quite like using those for some things. I use those more on sort of modern Macs than I do on these old vintage ones. Okay, so no, actually, reefers really aren't that bad. Reefers seem like they're really bad because they explode and smoke, but you just replace them. I mean, they generally don't do damage to the rest of the board. That's kind of what they're there for. They're designed as a filter, and so I mean, you know, if they pop, you just take them out and put a new one in. So I would take a reefer over a battery any day, or a surface made electrolytic capacitor for that matter. Electrolyte sedimentation rate, I like that. It's something specific resistance, I think. But anyhow, I don't know. And apparently if you go up too many steps in voltage from the capacitor you're replacing, you can end up with a different ESR. And in particular, if you're using capacitors and things like audio equipment and stuff like that, you can end up getting hum and stuff like that. So anyhow, that's just what I've been told. I'm no electronics engineer. I'm a programmer. So ask me questions about programming. Capacitor lead pitch must also be correct. That is exactly right. You want to make sure that the distance between the leads is the same as the hole. And this is one of the reasons why I don't have the part numbers on my website, because I don't have the you got to measure these things before you go and find the part numbers, and I haven't done that. So this is the guide that I'm talking about that you can't use because it's for a completely different power supply. You can't use for this one anyway. Okay, I'm going to just quickly do something here. So I'm just looking up something here very quickly. It's equivalent series resistance. That's the ESR. I think that's equivalent series resistance. There you go. Now we know. It doesn't help us, but that's what it stands for. Thank you, Christopher, for coming up with that before I went and looked at it. All right, so I am taking a really long time with this, so I'm going to try and step it up a little bit. And how would I do that? I would do that with my fancy pants soldering desuckery tool. So I'm going to jump across here to a side view, side angle, put my big magnifying glasses on so I can see what I'm doing. I must remember to do hotkeys. So I'm just going to put this here because try and get a better view, and then we're just going to start removing capacitors a lot faster. Oh, they're over here. So we've got one here. Oh, this has got to heat up. Sorry, this cools down when you leave it for a while. I'm just going to wait for it to heat up so it can melt solder. I think it should be there now. Melting, sucking, melting, sucking, and I'm off camera. Okay, so there's another capacitor that comes out, and he is 1000 microfarad, 10 volt. 1000, 10 volt. Okay. And this one. Melting, sucking, melting, sucking. Okay. And this one to down there, 470/16. So interestingly enough, the other one just uses 10 volt and 25 volt. So this one's already got a 16 in here. So we've got some variation there. The one here. So if you're doing a lot of these, I definitely think you can see the value in having one of these if you're doing a lot of removal of these sort of caps. This is a big fat one, and this is 1216. Nope. 12. Actually, can I write it on there? 1216. 1216 volt. I'm just going to hang on to all these in case I can't read my writing. I can at least get close. Another one. Anyone who's ever had to do a lot of desoldering and doesn't own one of these, when you watch someone using one, you go, oh, that would make my life so much easier. 2200. 10. There we go. And then we've got two little ones. One here. Now, obviously, you can see that I'm looking at this fairly intently. I'm not reading the chat at the moment, but I will read it once I get all these off. This is a 120 10 volt. They're both the same. 120 microfarad 10 volt. Okay. That is that. There's the 120 microfarad 10 volt. So they're both the same. 120 10 volt. Right, so now we have to figure out what I actually have. Oh, I'm also going to check and see how it compares to what the other power supply does. Okay, having a look here. It's more annoying than damaging the beam. Rather painful board. Consolidating coolant resistance. Damn, that sucker is nice. The want is strong. Do you plan on replacing that giant cap, Bruce? No, I don't plan on replacing it. A couple of reasons why. The first reason is that they are typically not a point of failure, these great big ones on sort of this side of the power supply. And the other is that they are expensive and quite difficult to source, some of these ones. This one is 180 microfarad with 400 working volts. So, yeah. This might look like it's bulging at the top, but I can tell you it is not. That is a plastic cap that sits on top of the aluminium, and they always bulge up, and they trick people all the time. The number of times I've seen people go, oh, look at this cap, it's got a bulge on the top, it needs to be replaced. It's not a bulge. This plastic does tend to bulge, but the capacitor, the aluminium underneath it, will be absolutely flat as a pancake, I guarantee it. I mean, I could demonstrate it, but it would then mean I was taking that plastic cap off, and I don't want to. If you want to do it on your own, feel free. What you do is you get a scalpel blade, like this. You put it underneath here, and you slide around and cut that little plastic ring off the top, and then you can take the cap off, and then you can have a look at the top of the capacitor. And I promise you, it will be absolutely and totally, completely flat. So, there. Right, so we've got all of those old caps off. I've got them all labelled here for what I need. Let me just have a quick look here. We've got... Nope, they're all very different. I think there's like only... Nope, I don't think there's one the same. So now is the point where I find out whether I have them. So I need 10s, 16s, and 25s. So let's grab my 16s from my little precarious pile here. I've already got my 10s and 25s here in preparation. So, 16, I have one 470 16. Or 70 16. Happy day. That's it. Oh, hang on, that one was 1200 16. Happy day. 1216, 470 16. So that's good. That's all for the 16s. Let's have a look at the 10s now. Now, of course, I may need to go back to my 16s because I may not have what I need here in 10s. So we've got a 120 volt 10. Now, that's a little one, isn't it? Sorry, 120 microfarad. Nothing wrong with my figuring. And of course, if I don't have these, I will have to order them, and I won't be able to finish this recapping today, which happened with my SE30 recap recently. How annoying was that? Of course, I've got all the caps for the SE30 now. But so, right. Well, first up, we're looking at a 120 microfarad 10 volt. And I definitely don't have that, so I'll have to see if I've got a 120 in a 16, possibly even a 25. But we'll see. My friends are discussing. Okay, so then what else do we have? 10 volt. We have 1010. Oh, I've got a 1010. 2210. 2210. There were two 2210s, were there? 2210? 22, there were. Wasn't paying attention, was I? No. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So I'm missing 3. And then we need to look here at 25. I should zoom out a bit, shouldn't I? This is a little bit zoomed in for the work that I'm doing at the moment. Any idea why the big one doesn't go bad? Well, it's not even necessarily that it doesn't go bad. It's just it's not. They're generally what really makes a capacitor fail is when it's being used outside of its spec. Well, I mean, obviously age, but all electrolytic capacitors have a limited lifespan, and that lifespan is based on them running at their maximum temperature. So when you buy any capacitors, they actually say how many hours they're going to run for. You can buy them with like 1,000 hours, 2,000 hours, 5,000 hours. And you might look at that and you think, well, that's not that much time. That's going to, die very soon. But it's the lifetime based on it running at its absolute maximum temperature. And the heat is what dries out the electrolyte liquid, and that's what then causes them to fail, or leakage, of course, if they haven't been made properly. And what, of course, pushes a capacitor up to its higher temperature is when it's being run, sort of at or above, its rating. So if it's actually being pushed to its limit, it's going to get hotter, and then it'll die out sooner. These great big fat ones are usually run a lot lower than their designated spec. So they're not being pushed to the limit as much, and so they generally last longer for that reason. So I desoldered the large cap just to take a look under it. It would probably have the same seals as the others, which are known to disintegrate over time. Yes, you're probably right, and I will do that. I will definitely do that. Right, let's see what we can find here. Well, I think I'm going to be stuffed with 120, because I don't think I've got to go back to the 16. So 25, 47, 47, 25. I have a 47, 25. Any advance on 47, 25? There we go. There's that. So 1, 2, 5, 6, 8. I've got 1, 2, 3, 4, 5, 6. So I'm basically missing 2, and they are 120 microfarad. Now, I've got a sneaking suspicion I don't have any of that size, but we'll see. 120 just isn't a number that sits in my head. No, it's not. So I'm not going to be able to replace 2 of the capacitors on this, which is a real shame. But as I say, I didn't know that that this was the situation. I'll just have a quick look here. Sometimes some don't end up in the same place, in the right place. Yep. No. So that I'm going to have to order some 120 microfarad 10 volt, and I will do that in order to finish this off. They generally don't take long to arrive. The supplier that I use, which is RS Components, not advertising them, but if you're in Australia and you're wanting to buy components, I recommend them. Free next day delivery with no minimum order size. So that's why I use them. So disappointment in that we won't be able to finish this recapping, but at least we're sort of discovering that it's that there are these I was discovering there are 2 different power supply types. All right, so we're going to do this. We're going to take this great big fat cap off. Let's get this fat cap off. Let me just get this around here. Right, so how the best last missing a cap. Yes, what happened? Missing a cap. Yes, I am indeed. Because this is a different power supply to the one that I previously done my guide and recappings with, there is a particular rating of capacitor here that I don't have, and it's a 120 microfarad 10 volt. Would have been happy with a 16, might have even considered putting a 25 on it, but I don't have any 120 microfarad. I mean, none. So I'm going to have to order some. But I will be able to put all of the other caps on apart from that one. But what we're going to do here, just for a little bit of fun, is we are going to need to change the size of the nozzle on this, because the pins on this big capacitor are thicker than the little hole in this. So I'm just going to grab a larger one. Okay, they fit on that one. I might actually go the bigger one. So now this one here is not like my fancy Hacko where you can just remove pin tips while they're hot. No, this one here, this is hot. This is hot. If I tried to undo this with my bare hands, I'd be melting myself. Whoa. Just take that off there. We don't want to melt anything there. And then we'll get, which one did I decide? The big one, I think I decided. Yeah. So pop that on there. And then pick this up very, very sheepishly with pliers. And pop it on there. And do it up. This is not ideal. What's better is to let it cool down and then remove it. But, you know, that's a bit dull for a live stream, is it not? Right. So, one of these tips is hot and one of them isn't. I will pretend they're both hot. There we go. Alright, so we just need to wait for this to heat up a little bit. Oh, that was a hot one. It's got a little burn mark on the paper. So we definitely know that was a hot one. Okay. Yep, I'm making little burn marks on the paper with the end of this tip. So let's undo this here. Yes, sort of. Another thing really important with capacitors is the fact that even if they're not used at their peak, other things can influence the temperature of them. Like, for instance, positioning on a board. They might be right next to a heatsink, and there might be heat coming off that heatsink, which heats up the capacitor. And that is going to reduce its lifespan. So things like board design can also have a part to play in it. Okay, well that is the pins on my great big cap. And out she comes. And I don't see any leakage there. There's sort of a little bit of discoloration in there, but there's definitely no leakage, so that's a good thing. We can be happy about that. So there we go, that was fun. I'm just having a good old look under that there. It looks pretty good to me. So unless there are any objections, I'm going to put it back on. Let's get some solder. And let's get some glasses. Sorry about it, how bright it is. I'm going to go through so much solder with this because I use this really thin stuff for little tiny components, but this is a great big fat one, so I'm just using a huge amount of solder. Okay. Whoops. I know you object to everything, Jay. Just learn to deal with that. Oh, what did I just melt? This landed on some plastic. So now I've got the smell of burning plastic in here. Isn't that lovely? Lovely. Okay. Did you mark polarity? Well, thankfully this board actually has the little plus sign stenciled on it. It's actually got a couple of things. It has... oh god, that plastic stinks. It has... this big thick bit here is indicating the negative, and the little plus is indicating the positive. So polarity is indicated for me on the board, so that saves me from having to worry about it, which is nice. It's very good. It's a good thing. Right, so let's start putting some of these capacitors back. Did you reverse the polarity? See, there's a Doctor Who reference there. For anyone who knows that anytime Doctor Who gets himself or herself into a pickle, I'm thinking probably more of the older ones when it was a he. Whenever he would get himself in a pickle, the answer was to reverse the polarity. Oh, this electronic lock won't open. Let's reverse the polarity. Lock undoes. So there we go. I'm just going to reduce the brightness slightly on the camera here because it is blowing out just a smidge. Sorry for the wobble. Let's go the wrong way. Oh, there we go. There we go. That's it. All right. Sorry then. It's probably the same as it was before, but never mind. Or maybe now it's too dark. It's probably just this white paper that's making it seem so bright. All right. Now, boy, I am really taking a long time to get to the point, aren't I? Let's get our two 2200 microfarad 10 volt. So there's my 2200 microfarad 10 volt, and they are in the position of here. Zoom. God, that thing is still wobbling. Stop it. There's a bit of a breeze outside. I think that's doing it. Okay, so we've got one here, and we've got one here. These two there. They're both 2200 10 volt. So once again, I know that the plus goes to the minus goes to the big fat blue line. The plus goes to the little plus sign there. There's one, and here's another. Now you might notice that these are smaller than the originals, and that's basically because of technology. They're able to make these capacitors smaller these days than they used to be able to. And I just bend, out of focus. I bend these pins so they don't fall out. I don't bend them a long way, I just bend them a little bit so they don't fall out. Then I pop it upside down, whip over to my microscope, take my silly glasses off, and then we can start soldering. So I have shown how I do through-hole stuff before, and what I generally do is I just solder one pin first, like this. Good. And then I put my hand underneath the board. Let's see if I can focus while having my hand under there. I'm wiggling the cap now, and what I do is I then apply some heat to remelt this solder and just push the cap in until it's sitting flush on the board. Okay, and then I can solder the other side. And that's my method. And let's do another one. And then hand underneath. Remelt. Push flush. And then solder the other one. So I'm having to refocus all the time because I'm moving closer and further away from the microscope all the time. Okay, so then we just need to, I need to do quick keys of these angles, don't I? Then we just need to snippety snoop these. It's too dark now, isn't it? Snippety snoop, snippety snoop, snippety snoop. And then we've got two replacements on there with the correct polarity and the correct capacitance, which is always good. So 1200 microfarad, 16 volt. Okay, then do they make them more durable as well in terms of the capacitors? There are probably more choices available these days in terms of buying capacitors with longer lifespans. I definitely buy longer lifespan ones. So your standard capacitor, I mean, my guess is that at the time they put these power supplies together, they were probably using 1,000 or 2,000 hour lifetime capacitors. I generally replace all of them with 5,000 hour capacitors. So in theory, these new capacitors I'm going to be putting in will last longer than the originals. But do keep in mind, of course, there was that capacitor plague in the 1990s, late 90s, early 2000s, where there were a lot of capacitors being made faulty and which were failing way earlier. Well, that is apparently behind us now. So in theory, yes, these capacitors should last a very long time, should be more durable than the originals. And I always replace these with 105 degree ones rather than 85. These are probably all 105s anyway. 105. the originals. This is a Rubicon. Can't see the temperature. Here we are. That's 105. So, yeah, but anyhow, so yeah, I basically, when I'm doing this recapping, the idea is that they won't have to recap it again, hopefully ever, but, you know, depending how long these, you know, I mean, who knows what might fail next. I mean, this is the situation at the moment, is all these things need recapping. Maybe in the future there'll be other things that start failing. So, can you hold up your finished drawing so you can take a screenshot? It's pretty bad. I mean, yes, I can. I will make a guide. You see, you can't even tell my 1s from my 7s, can you? But anyhow, I will come up with something slightly better than that in the future, don't worry. Alright, so are you playing along at home, Steve? Do you have the same power supply as this? I'm curious to know. I'm curious to know if the power supplies in yours are the Astec type. Okay. Capacitor polarity is more of a suggestion, right? Yeah, it's just a guideline. Just a guideline, yeah. 1200 16 volt. So that goes into this little hole in here, and it was, the original one was this one here. It's quite a short, fat one. This one's a taller, thinner one. But it's got the same lead spacing, so it'll be fine. And it's not too tall. It still fits inside the power supply. Minus plus. I did actually, in one of my previous videos, I was saying, you know, because one of the things that people ask me all the time is, oh, I do a search online for capacitors and I just find millions of them. Which one should I buy? And I did talk once about how there are a few things you want to keep an eye out for, and they are things like the what do you call it, the temperature, what do they call it, the operating temperature. Make sure that's the higher ones, go with 105 rather than 85. Make sure the lead spacing is right. Make sure that the capacitor is going to fit into the space that you're putting it in. Make sure it's the right height and width. Doesn't matter if they're a little bit smaller, but it certainly matters if they're bigger. You know, if they're too tall to fit in the gap or too fat to fit in the gap. So that's one thing. Always look at the lifetime of the capacitor. The higher is better generally. And of course, I'll keep price in mind as well. I mean, you know, if you're doing a full recapping job and you end up buying the most expensive capacitors, you could end up costing an absolute fortune. And brand is also a good thing. I generally go with the well-known brands like Nichicon or Rubicon or Panasonic. Of course, they apparently make really good caps. They make really good long life caps, so worth keeping that in mind. I generally sort of buy a lot of Panasonics these days. Oh, look at this. This is a discussion going on here. I'm having this discussion and it's going on in the chat at the same time. Okay. For label appears shipped when it's a manufacturer. Yeah, so I've flipped it over here, but Jay, what we were wanting you to look at was, no, it's the labels underneath here. I'll show you later. This way it's Astec. We have 2 TDK LC style PCUs. So, crap, I don't know. What's the one in my screenshot? That's the one I recapped in the thumbnail of this video. That's the one that I've recapped in the past. It's not this one. So yeah, if you have a look, I'm pretty sure the ones that are in the screen snap are TDK, in which case, if they are TDK, then this guide that I have here is what you want, which is on my website. All right, let me get this out of the way. All right, we're working our way through the Astec. So this is Astec. Right, so it's frustrating to know that I won't be able to finish this, isn't it? But that's life. So we've got a 1010 1000 microfarad 10 volt. And he goes over here. And once again, just making sure I get that polarity right. This is quite good, this board, the way it's got these big thick lines showing where the negative is. So you can just sort of glance down really quickly and see that you've got them on the right way. Bending our pins. Switching over to microscope. And begin. Of course, I do have to try and finish by 1 p.m. in my time, which is in about 35 minutes from now. But I do believe I'll be finished before then anyway. Because we're getting very close to completion here, apart from the fact that I can't do one cap. I might just investigate, I think I might investigate whether my local electronics company has the cap, but I don't particularly like their caps, to be honest. I'd rather wait and order good ones in. Okay, that's another cap in place. Yeah, Danny has just mentioned the fact that electronics wholesalers have filters that you can use to find the caps you want. Some of the filters I don't particularly like. They don't have some of the things that I want to be able to filter out. That's one of the reasons why I quite like the RS Components one. I find that their filter has a lot more options you can apply to it to weed out, sort of the ones you don't want. You're missing. Why not just put it back for now in the off chance it's okay? Well, look, it probably is okay. It's one of these little tiny ones, and these little tiny ones are usually not as bad as the microscope big. Are generally not as bad as the sort of these medium-sized ones. These medium-sized ones are usually far more prone to leakage. Having said that, of course, this is the one that was leaky, and that's a little one. Yes, you're right. I could put them in, and we could sort of test it out if you like. Yeah, all right. I'll do that. I'll put it back in, so at least we can switch it on and test it out, and we get that sense of satisfaction of doing something. And then I'm going to have to pull it all apart again. Not to worry. All right. So this is 470/16, which goes down here. Once again, that's the negative. Now this is a bit of a squeezy fit. It does fit, but geez, not by much. They're very close together. The original ones are tall, thin ones, I think. Yeah, it's a 470/16. As you can see, it's a thin, very thin one. And this is a... What was it sitting next to? The 10 one. Okay, so it was using the thinness of that one to fill that gap. But this, look, it's squeezy, but it fits. So I'm okay with it. But I don't think I'll need to push that in when I solder it, because it's being held in with a bit of friction. Microscope. Hi, Chris Isherwood. Does your multimeter have a capacitance range? Yes, it does. Oh, you want me to test them, don't you? That's what you want me to do. Right, and then sort of last, we have this little guy here, which is my 47 microfarad 25 volt, which is going to live just... Oh yeah, that was the one that was leaking, so I'm going to isopropyl that a little bit. Come on, isopropyl. Sorry about the lack of focus. I've got the microscope set up. Oh dear, oh dear. This is my little dispenser. Running a little on the low side. isopropyl alcohol, 99.997. Makes good hand sanitizer as well. Diluted out to about sort of probably about 70%. So 70% isopropyl, 30% water, and then just a few drops of glycerine in it. Glycerine helps the really the damaging effect of the alcohol on your hands. So if you decide you want to make your own hand sanitizer, if you don't, just ignore everything I just said. Okay. Just going to clean that up a bit, and we're not looking through the microscope again. There we go. Cleaning up some goop. Goop not good. Okay. Pass it through the hole. Bending of pins. And some solder or solder, depending on which part of the world you come from. Solder. Where is it? There it is. Pushing up. And that flush. And focus back down again. And snippity snoop. Sorry, I haven't been looking at the chat, have I? Right, so any sort of, yes, you're right. I think it is usually made from methyl alcohol, but trust me, that ISO works. I tell you, very good at disinfecting. Yeah, that's why you would put the glycerin in. It removes the irritants from it. I've actually been using it. I actually mixed up. You can just buy this aloe vera gel, and I just mixed up some aloe vera gel with isopropyl alcohol. And it's a lovely hand sanitizer. It doesn't irritate the hands at all. I have one of these. Has anyone seen one of these before? This is a little electronics kit that I put together, and it's a little sort of component tester. It's quite cute. It works quite well. I'm going to give it some power. I'm going to find my plug. Is that my plug? Nope. I really should have a proper power supply or a battery or something powering this up, but I don't. I power it up using... here it is. Using this little plug here. Connected to this, and I think it runs off 9 volts. I want to check that, wouldn't I? 9 volts, there we go, it's written on it, so that's cool. So let's set the old, you're not going to be able to see this, but I'm going to set the old bench power supply here to 9 volts. I'm going to grab that, let's touch them together and woo, woo, make some sparks. Woo, woo, woo. Okay, now we put the black on the black. We put the red on the red. Then we put the wine in the coconut. Connect that up. And then in theory, if I press that, it comes on. Ta-da! Let's see if I can get the zooming in on that. Damaged, no unknown or damaged part. Right. So, it's too dark again now. Sorry about that. We'll just have to sit here and watch this wobble for a while again. And let's just test this component, shall we? This was the one, I think, wasn't it? 10 microfarad, 10 volts, 120 microfarad, 10 volts. So I'm going to put these pins into these little testing holes here. I close that to clamp it down so that they're getting power. Then I'll switch him on and let's see what he says. Okay, it knows it's a capacitor, and it is finding that it is a 126 microfarad. There you go. That's all right. That's certainly within about a, that's within a 10% tolerance there. So, cool. Let's try another one, shall we? There's this one. 10. In you go. Oh, these leads aren't very long, so let's just see. On. There we go. I'll be honest with these things. For me, the joy is 121, so that one's even better than the last one. With these, the joy of these is actually building them. I love building kits. I'm just a huge fan of making kits. But this one is one that has a really good practical purpose. As I say, I need to put a battery inside this, so it's a lot easier, make it easier to power it up and everything. But yeah, it's a beaut little thing. And it doesn't just do capacitors. It does capacitors. It does. I mean, look, I'll show you some of the other things it does. It does resistance. It does. I think it does resistance. I'm looking for something with my eyes. Here we go. This is some sort of transistor. Let's see if it can recognize what it is. We'll see. We'll see. See, I'm putting it to its test. Oh god, these pins are a bit fat to get in there, but they're getting in there. Okay, well, I can't close it. Right, let's see what it does with this thing in here. Apart from not switch on. Switch on. There we go. Its auto power off is a little bit quick. Oh, look at that. NPN. So it was able to work out what it was very easily. You can see there's the emitter. Pin 1 is the emitter. Pin 2 is the collector. 3 is the base. So there you go. That was able to tell that it was a transistor. Nifty. Okay. All right. That's enough. But anyhow, I should probably put a link to these kits in the description. But I think from memory, I bought this one either from like, what is it? It's either like Banggood or what was that other one? Oh, someone worked with me. Or what's that website that sells all those kits and things like that? Can't remember the name of it. AliExpress. It might have been AliExpress. I'm not sure. But anyhow, they're really nifty little thing. Do really like these. They're nice. Okay, so what we have established is that these capacitors are certainly still functioning within range. That doesn't mean that I'm not going to buy new ones and replace them before I give this back to the customer. But for the purposes of testing today, we can put these back in, and we know that they're not necessarily going to be the cause of any problems. So it wasn't out of fruit. I can't remember which one it was. I think it was AliExpress or Banggood. I can't remember. Okay. For repaired original power supplies. I think it would be cool for testing, but would prefer repaired original power supplies. What is the name of the kit? Yeah, I'll have to look up my purchase history, and give you all the details, Greg. But someone else I know had one of these, and he was saying, "Oh, look, yours is different to mine because this one has a little push button here, and then as well as you scroll this around to do all your settings and stuff like that. And his was different. His didn't have the push button and scroll. It was just scroll or something like that, or had 2 buttons on it. This one, it's really good, very good, very happy." Right, so let's put these capacitors back on, just so that we can test this, so that everyone can feel like they've actually seen something of interest. Oh god, you know what I did? I did something so stupid today. I took the cables back up to the house so in order for me to connect the monitor to the 475. So I will have to duck up to the house once I get this back on. Now this is a little bit tricky because I cut the leads before, so they're really short. Right, I'm going to need to probably hold this in place. And how am I going to do this? How am I going to hold it in place while soldering it so that it doesn't fall out? I need a third hand. What I can do is just try and tack it a little bit. So I'll get some solder on my iron, and then I'll just try and melt that onto there enough to just hold it in place, which I believe I have done. Yeah, I mean, they do actually sell pre-built ones of these, and my answer to that is, where's the fun in that? But that's just me. Alright, so let's get that one soldered, and then let's neaten up this one that I just tacked on. Looking good. Right. Hello, Peter. Welcome. I didn't notice you joined the stream before. Do I pronounce your name Peter or Peter? 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 I don't know. I'm not sure. So this goes in here. I'm struggling a bit here. Get in there. There we go. Ha. There's my pins. So once again, I'm just going to try and do Petar. Petar. Okay, no worries. Now I know. See, I would have just sort of said Peter before, because I tell you what, in Australia, people would probably just end up calling you Peter. We're terrible at pronouncing things the right way. Tack. Tack. There we go. That's tacked. Okay. Right. Okay, so that's all the caps on. I'll just have a quick look. And, oh, excellent. Found the kit and listed in our chat. Now, that, I think what I have to do here, it's not appearing, and I am going to turn you into a mod so that you can now, you should be able to post it in the chat now. It doesn't let you if you're not a mod. I don't think it frowns on URLs. There we go. Oh, here we go. Here we go. All right. Right. So, okay. So, that's all done. I might just give this a little bit of a clean. Let me just whip this over here to the old side angle. And I'll bring this here, and I've got a little bit of flux cleaner here in a bottle. I'm going to sprinkle some of that on liberally. Give that a bit of a scrub with a toothbrush. Scrubby, scrubby. Obviously on this side it's just little pins and stuff sticking out, so I can be pretty aggressive with this toothbrush. And then... oh no! I'm out of tissues. Out of tissues. What am I going to dry this with? Oh, it's drying itself. There we go. All fine. I would have liked to have dabbed it off. I will, of course, give this a proper clean before I put it all together good and proper. What we are doing for the moment is we are just checking to see it's all going to work. So, as usual, whenever I do any sort of recapping, the first thing I do is make sure that everything is being put in the right place. I always make sure that everything's the right polarity. So I'm now going to just have a look. Make sure all the right polarity. Good and good. And good. I've even got a photo. I took a photo of this before I started working, so I can look at that. Okay, looking. Right. That's fine. I'm just comparing it with the little stripes on my photo. Looking good. Looking good as well. That's great. All right. So, in theory, this power supply should now be working. Well, I mean, it was probably working before, but now I'll be working with gusto. So I need to reconnect my mains power leads here. Do the diodes look fine? Yep. Yep. Yep, I have to admit, I mean, I'm not terribly familiar with this board. This is the first time I've actually looked at it, so. But, you know, she's looking good. And I am going to attach the live into the live. There we go. I'm just going to solder that first. I'm not going to do this in a microscope because it's just too difficult. There we go. I just don't want that wire to be getting yanked while I'm soldering it. Okay. Let's make sure to recap the power. Right. Moving right along here. Who would have thought this would take so long? Boy, I do tend to jibber jabber. Come on through. There we go. Incidentally, Peter, I love that Mac that you posted. I think it was on Facebook, where you put a whole bunch of cards in it, and you were running all different instances on the same computer. It's an old Mac 2 or a 2FX or a 2X or something like that. That thing is awesome. Okay. That in there. I'm going to screw this down. I'm probably not going to put the whole thing completely back together again because, you know, I'm going to have to pull it apart again. But I'm at least going to just make it so it doesn't fall apart. Anyway, I think I need a magnet on this. What do you reckon? Oh, put the paper back in. Thank you. Thank you. Thank you. Which way did it go? This little, it just fell down, didn't it? That little thing just went into a slit there like that. Was that the slit there? That was the slit. Okay. That's where it goes. And that goes in there. There we go. My gloves are falling apart, aren't they? Oh, shuzbutt. There we go. All right. Oh, boy, what's happened there? Okay. There we go. I don't think this is the right size screw. What do you reckon? Yep, not the right size screw. What about this one? Is this one a little fatter? Nope, that's not it either. Can't be that one. I don't think it can be that one. I mean, I only took a handful of screws out of it. Must be this one. Must be. Yeah, Mac 2, 5 radius rockets, and an Apple high-res card. Currently, I pulled one of the cards due to overdrawing the power supply, resulting in constant bus errors. Currently rendering with 4 cards and a 2 seconds 720p. Wow, that's just awesome. I just love that. I love that sort of stuff. Okay, look, I'm not certain that's the right screw. Maybe, but I will get it right when I put it together proper. I think it has to be. I don't think there's another screw that would match it. That one goes there. That one goes there. And that one goes there. Yeah, it has to be that screw. It's the only one left. Right. Now, the only other screw I'm going to put in is this one here. I could probably go without it, but what this one does is it helps pull that piece of metal up against this case, which helps distribute that heat from those components onto the side case of this power supply. Come on. There we go. There we go. So as you can see inside here, you probably can't see very well, but there's a piece of metal running along here, and that's a heat sink for all of these components clipped onto it, and then it sits flush on this here. When I put this back together final, I'll probably put a little bit of thermal compound on here just to help that make better contact and better, you know, sort of heat dispersion onto that. Might be time for a new glove. What do you reckon? Okay. Can I get it in here? Can I get my great big fat hand in here now that it's all wet? Yeah, went on good. That's good. Excellent. All right. All right. So let me have a look here. So I think he, GT actually put it in our group chat. I could be wrong. So rather than in the live chat. But anyhow. All right. So here's my power supply. It is recapped, sort of. It's got mostly new caps, with a couple of exceptions because I didn't have them in stock, which I'm going to buy and replace it in the future. But for now, we do have these caps in place, and so we can test this out. I have got the LC sitting over here, and I might need to zoom out a smidge. Let's just get this off, out of the way, and then we can at least get some satisfaction. Right. I just put a hole in this brand new glove. I'm horrified. So I'm not going to put the cover on. What I'm doing is very unsafe. Don't do the same. This is not what you do. Don't be like Bruce. Okay, power supply in. That on there. So, if you will bear with me just for a couple of moments. Battery. I am going to just duck up, grab a couple of things from the house. So please sit tight, talk amongst yourselves, and I will be back. It literally will only take me about a minute, so I'll be right back. In the meantime, let me just do this. Look at that CPU sitting right in the middle of the camera. Yeah, look at that, 68040. There we go. Enjoy. Back in a moment. Okay, well, I'm back. So, zooming out. I've got a couple of things here. I have. Does anyone know what this is? And I've got a cable, and I've got one of these little adapters, and another one of these little adapters. This is the one that I use generally for the really early Macs, like the 2CI and the 2SI. They output a slightly different signal, and these ones here don't like it. These ones with only one row of pins, or they've got 7 pins. I think the ones with 9 or 10 pins, they work with them. This one here, inside here, this has 2 rows of pins. So this one does all sorts of different outputs, and this one, I just had this permanently set up for when I'm testing a 2SI or a 2CI, those early Macs. So, but this one here, with it being a 475, should be able to use the later sort. Okay. Oh, you're back. Yeah, I mean, I don't think you missed that much, other than finding out that this particular power supply uses one capacitor that I don't have in stock, so I have to order it in. But in the meantime, we've got the original ones in there just for the purpose of testing, so that all of the audience here that are watching at the moment, and right at the moment there are 30 of you. Thank you to everyone, to all of you folks who have joined on. This is probably one of my largest audiences I've had. I do appreciate that. Thank you very much. Obviously, there's the pull of the LC. I will probably live stream recapping this board as well later, and won't be able to do that today, but I will be doing that in a later stream. So yes, that is quite correct. This is a floppy emu. This is a version 5.5. Anyone who wants to find out a little bit more about the floppy, sorry, it's not a floppy emu, it's a SCSI to SD. What am I talking about? What am I talking about? So it's a SCSI to SD version 5.5. I have a video on the SCSI to SD where I talk about all the different types of SCSI to SD if you want to find out more about them. This one is a really good one for testing, because this is a computer has no floppy drive and hard drive. I can just plug this in and boot up. I have system 7.1 on this. It's loaded up with a whole stack of system enablers so that I can boot this off virtually any computer that will run system 7.1. And it's also got a bunch of utilities on there, so if I'm connecting a hard drive up, I can then format the hard drive, that sort of thing. So I will be doing a video on SCSI to SD later, and one of the reasons for that is that another video, I'm going to be doing one about how to set one up in a compact Mac or an old Mac. The reason why I'm doing that is because on Facebook, I just regularly see people saying, I'm trying to set up my SCSI to SD, I'm having trouble, I followed this guide, and they have a link to a guide on one of the old forums, I don't remember which one, and I don't like that guide. It has a purpose, don't get me wrong, I'm not actually criticizing the guide, but that guide is written by someone who is telling you how to set up a SCSI to SD so that it can be formatted with the original formatter tool that came with the system. So in other words, you trick your computer into thinking that it's a hard drive that is kind of compliant for that formatter. If you try and set it up as anything other than the drives that it has in its list, it won't allow you to format it. I don't agree with doing it that way. I think you're better off just formatting it. Don't worry about what sort of drive specs you set up it with, and use a formatting utility that doesn't mind what sort of drive it is. Whether that be using Silver Lining. My personal favorite is Hard Disk Toolkit, or Lido. That would be my recommendation. When you fire those up, they don't have an issue with the fact that it doesn't come up as a Seagate or an old Quantum or something like that. They'll format anything. So I am going to be doing a guide along those lines soon about setting them up, installing them probably in a compact Mac. So, okay, so yes, Oz RetroComp, is the version 6 worth getting over the version 5.5? And Steve, Mac84, that is exactly right. The main difference between the version 5 and... Well, there are two main differences between the version 5 and the version 6. The version 5, the version 6 does asynchronous transfers, so it's sending data in both directions at the same time. However, these old Macs only support synchronous transfers. So already you're paying for a feature that these old Macs are not going to be able to use. The other thing that the version 6 will do is if you plug the version 6 in via the little USB plug and you connect it up to a computer, it will actually mount the drive straight onto the computer via that. With these, if you want to mount the drive, you've got to take the card out and plug it into a card reader on your computer, you know, on a modern computer. And when I say modern, not too modern, because if it's too modern, you'll only be able to read it, you won't be able to write to it, because modern computers won't allow you to write to an old format, file format such as this old file formatting. So you'd need to run it on a 10.4 or a 10.5 computer and put the card in, and then you can read and write it. So anyhow, I digress. We're testing, aren't we? So we are going to plug in our SCSI to SD version 5.5 here. Incidentally, this is a nice sort of molded case here. They originally used to come out with a 3D printed one, but they now use this molded case. They sent me one as a sample to try out, and I have to say it's made well. The old one was made pretty poorly. This new one, as in the 3D printing, was pretty lousy, but this new one is very good. I still have one issue with it though, and that is that this part of the plastic hangs out too far, and then when you try and plug it into some computers, it won't go in all the way, particularly like a Macintosh LC. What I've done to get around that is I've actually shaved a bit of this plastic off there. But that's just I mean, I look at things very Mac-centrically, and the people that are making these aren't necessarily saying all for Macs, because there are other computers that use SCSI, not just Macs. So, let's plug in our... I've got to be gentle with this thing, I tell you, that plastic is just ready to give. I'm going to get this. I've got my little screen here, which is connected to a power cable, and if I'm not careful, I might end up accidentally disconnecting the other camera by doing this. But let's just see if I can get power. Yes, it's got power. So I'll switch him on. I think he's set on VGA at the moment. I'm going to plug that into there. Isn't that a cute little screen? It's so cute. Right. So there we go. I've got that. What do I have? What am I missing? What am I missing? I'm missing mains power. So we're going to plug in 240 of the finest Australian volts. And in we go. And this is the moment of truth. Ultimately, we want this to start up and potentially chime and all that sort of stuff. I see no reason why it won't. But, you know, I mean, for the sake of having an exciting stream, maybe it'll go or something. We'll see. There's the screen. And ready. Well, the fan is spinning. We didn't get a chime, but that, of course, can be from recapping. I'm fairly confident about the power supply at the moment because, you know, the fan is spinning. So, I mean, if it wasn't spitting out power, we wouldn't have a spinning fan. I saw a little flicker of a light on the SCSI to SD, which is good. Oh, yeah, that's got everything in it. Yeah, I was going to say, oh, it needs VRAM, but it has VRAM. Oh, hang on, there we go. There's a light just come on the SCSI to SD again. It's doing a blinky thing, so let me just make sure I've got this on the right input. Oh, there we go. So I had it on it was switched off. Yeah, it's too bright. Just let me do a couple of things here very quickly. Settings. Let's go here to display ratio. Let's change it to 6:3. Bing, bing, bing. And then we go here to menu, and then we go down here to settings once again, and we go to there's some auto setup. Where is it? Auto config. There we go. Auto config, and bing, and then up. And okay, sorry, I'm doing something here which is extremely boring. Okay, so what I'm now going to do is just change the brightness on the camera so that you can actually see the screen. And so that's me wobbling the screen now. I'm going to dim it. It's going to be very dim, but that's because you can then see what's on the screen. So, Jay, thank you for that. Appreciate it. Another Oh, well, that's a super sticker, that one, is it? Or is that a super chat? I'm not sure. I'm still so new to this. Okay, so there's that. Now, we're getting a flashing question mark. I'm going to just pull out this. Oh, actually, I know why we're getting a flashing question mark. And it's to do with SCSI termination. On this particular computer, if you don't have a drive in here, it won't terminate correctly. So I need to have a stand for this, don't I? Either that or start running it on battery power so that I can move it wherever I want. So I can resolve this theoretically by connecting up a SCSI drive, which I have somewhere. I have SCSI drives floating around here. The drive doesn't even need to be powered on. It just needs to be plugged in to provide termination. So excuse me while I just try and find one. I mean, I have them here. I do. Ah, there we go. Here's one. It's actually 1 GB formatted. It might even boot off this, but all I'm going to do is I'm just going to switch this off. Going to plug in the hard drive in the dark, like that. And then switch them on again, and then what that should do is that should waiting. All right, so let me have a look at the chat while we wait here. Okay, there we go. Oh, we're booting. You know, we're booting off the SCSI 2SD at the moment, version 5.5. This is in system 7.1. So we have a booting. We obviously have no chime. We know why it has no chime, and that's because it has capacitor leakage. And it is a computer that is prone to capacitor leakage. But we know the power supply is working. We also know the clock is not set to the right time, because that's just how it goes. And you'll see that there it jumps up with quite a few partitions, because these old computers can only recognize up to 2 gigabytes in a partition. And so I have to break those up into lots of little partitions. So, all right. So that there is a successful one. I do have a mouse floating around somewhere here, but I'm just going to switch this off. And good night. So the power supply has been recapped with the exception of 2 capacitors, which are, well, sorry, I should say that 3 capacitors, which are the original, the great big fat one, and then 2 little tiny ones, which of course I didn't have replacements for. I will be replacing those ones. I'm gonna, as soon as I finish this stream, I'm gonna jump up and order some, and then I will I'll leave this open and I'll replace it. Then of course the other thing I need to do is recap this board with the hope that we get sound back. You know, we'll keep our fingers crossed with that one. I might just very quickly have a quick look at this board under the microscope just to see how it looks. Grudy, thank you very much. I tell you what, thank you guys for the super chats. I really appreciate it. It's really nice. It's nice. I appreciate the support. It is. I don't want you to think it is unappreciated. It is appreciated. I should actually take a few moments to mention a few of these people who have been doing these super chats. Rutke Mods, Greg Rutke. Obviously, if you haven't checked out his channel, Rutke Mods, jump on and have a look. He focuses on all sorts of stuff. I mean, you know, power PCs, you know, sort of iPods, you know, sort of Mac Pros, the whole thing. I mean, you know, there's a whole bunch of stuff that he covers on his YouTube channel, and it's well worth a look. And I tell you what, if you're not sure about that stuff, if you're not sure about, oh, is this going to work with my computer or not, he will know, and he's probably got a video on it. So anyhow, definitely check it out. Also, obviously, Mac84, Steve from Mac84, check out his channel. He does a lot of this vintage stuff. He's got some fantastic content on there as well. And of course, House of Moth, Jay. He's got some fantastic content on his channel as well. So, you know, jump onto the House of Moth YouTube channel. And then, of course, I would be doing us all a disservice if I didn't mention MacYak. For anyone here who is not aware of MacYak, it is a weekly show where a few people, including me, get together and chat about Macs. And just Macs in general, modern Macs, old Macs, Apple, iPods, iPhones, iPads, you know, the whole thing. Thank you, David. Thank you for the super chat. I appreciate it. And so yeah, do jump on and have a look at Mac Yak. We stream once a week. If you subscribe to the channel, you'll get a notification. Yeah, it's a bit of fun, just us sort of chatting about all things Mac and Apple. Now, to get this board out, I need to brighten the screen up again. Sorry, a little dark again. I have to find some way of doing this remotely, don't I? I can zoom remotely, but I can't change the brightness remotely. So in order to get this logic board out, the real challenge of this is that it is held in by plastic tabs here. And you have to push them out in order for the board to slide this way, that way. And, well, you know, I've talked about... Oh, there, that one came out. Phew, God, it makes your heart stop, I tell you. And there's a whole bunch of busted plastic under here. What is that under there? That's not meant to be there. I think this might be part of the case. Yeah, that's a missing bit of plastic from the case. A bit too bright now, sorry. I can probably glue that back on again, but I don't think it'll stay. All right, so board comes out. There we have it. Now let's put this again to one side. Let's get my little PRAM battery out of the way. And put this over here where I currently have absolutely no space whatsoever. Right, and then we'll just very quickly jump on and have a quick look at the microscope around the sound chip, seeing as this has no sound, and let's see if we can just see anything very, very quickly. And then we will sign off for the day. Everyone can get back to their thing, and it will be wonderful. Okay, so... Well, if there's leakage there, I've seen a lot worse. I mean, there's a lot of gunge around the sound chip. Scunge and gunge. If we're having a look around there, you can see how all of that dust and stuff is kind of yellowing, and that's because it's actually got some leakage on there. Oh, look at that! I got a super chat from my wife. That's it makes no sense. It's our money. What are you doing? What are you doing, honey? But thank you very much to my wife. So, okay, so yeah, we can definitely see that we got some scunge and grunge around here, and I think that's the reason why we're not getting sound. That's impacting on the sound chip. You probably find that even just a good clean of this board in its current state will get the sound back again. But we are going to recap it, and that ensures that it's sort of the problem is fixed rather than just getting rid of the symptom. We're getting rid of the cause as well. Okay, well, that's it from me. That is the LC475 power supply recapping. I don't have a lot of luck with power supplies, do I? I did do an SI one, but when I did my SE30, I was missing a couple of caps, which I have now. But you know, and then of course now I do the LC475, and I was missing a couple of caps. So, you know, I will eventually own every single size of capacitor known to human beings. But for the moment, there are still a couple of gaps in my collection. So in my stock, there are all my caps over here. Yeah. So thank you everyone for watching. I do appreciate you spending the time to watch today. It has been fun. It's as I say, probably been one of my more successful live streams. I'm currently sitting on 31 viewers, which is I think probably a record for me. Yeah, so thank you for taking the time and spending it here with me. And I will click the end stream button now so that I'm not left just hanging there making a silly face. So thanks again, guys, and we'll see you at the next one.